Hello, welcome back. The mean number of cars, or 817, 18. How do you recognize a normal distribution? I think the main thing, they're going to tell you whether it's a normal distribution. They're not going to try to trick you. So you recognize it when you look at a distribution. To look at one, it's just a bell shape. That's the main thing. It looks normal. But if they're giving you a problem, you have to solve it. They're not going to give you one that's not if they're solving it in that way. Here 19, this is labeling whether it's discrete or continuous. I think we talked about that earlier, so we won't talk about that one. Number 20, you basically got to find the z-score. You want to use this formula. Jack weighs 160 pounds and his sister weighs 110 pounds. If the mean weight for men his age is 175, the standard deviation of 14 pounds, and the mean weight for women is 145 with a standard deviation of 10 pounds. Determine whose weight is closer to average. Write your answer in terms of z-scores and areas under normal curve. Basically, you found the z for both, and average would have a z-score of 0. So here, since Jack's score is only 1.07 standard deviation below the mean, and his sister is 2.5 below the mean, then Jack is closer. Okay, so that's the main thing to look at here. And I noticed they found the area under the curve to the left of those values. So here, z of area is 0.1423. This area is 0.0062. And again, this is just the area to the left of those values. So that's it for that one. Here, this one you're doing again, you're going to do some calculations here from what they gave you. Okay, for this one, they give us a mean and a standard deviation, and this represents braking distance in meters of a certain car, and it tells us that it's normally distributed. Find the braking distance that corresponds to a z equals 1.8. Well, this 1.8 means it's 1.8 standard deviations above this 45.1, right? So I could just figure that out without even going through an entire process. I think the easiest way to approach this is simply, since it's 1.8 standard deviation, just go 1.8 times 0.5 and then add it to 45.1. And if you do that, you're gonna get, what's the value down here, 46. That's the easiest way to do that one. Part B says find the braking distance that corresponds to the 91st percentile. Well, the 91st percentile basically means that 91% is the area on the left. I have to find the value that corresponds to that. So what I'll do is go to mini tabs. That's probably the easiest place to do this. Remember 45.1 and standard deviation of 0.5. So I'm going to go to graph, probability distribution plot, here, go back to normal. My mean was 45.1. My standard deviation was, okay, it was 0.5 here. I'm going to go to shaded area. I'm going to input a probability. Since my area was to the left, I'm going to put left tail, and I'm going to put 0.91. It's going to give me the x value that corresponds when the area to the left is 0.91. Then I click OK. Here it is. My x value is 45.77. You can probably round that up to 46. And that's it for part B. For the rest of this problem, it's the same place. I would use mini tabs and use that graph function to solve each one of these problems. So, I think that's it for this section.